Hi everyone, my name is Rutuja and welcome back to Data to Crunch. For today's project, I have created one case study from scratch in which we are going to utilize one fictitious e-commerce company named as NovaCard. So this company was facing some challenges, and to overcome those challenges, we are going to build one modern lakehouse data platform. So first, let's have some background about this company. NovaCard is a rapidly growing e-commerce company that sells the consumer products. As company expanded, the volume of transactional data generated by its platform, it has also increased significantly. Every day, thousands of transactions were recorded in company's Azure SQL database, which mainly included customer orders, then product details, and then payment transactions. While the operational database it was sufficient for running the application, the analytics team it has began facing several challenges. Business stakeholders also needed the answers to the questions like, for example, which product categories are driving most of the revenue, or what percentage of orders are fully paid, or how does the payment behavior changes over the time period, and so on. However, generating these insights directly from the transactional database was very inefficient and risky too. Running these analytical queries on production database, it has also created performance bottleneck and it could also potentially impact customer facing applications. For this, Novacard's data engineering team has decided to build a modern data platform using Azure Databricks to support scalable analytics and reliable reporting. So the challenges that company was facing are as follows. So the first one was operational systems were not designed for the analytics. Azure SQL database, it was optimized for transactional workloads and complex analytical queries slowed down the system also impacted the application performance. Then there was no historical tracking. When the order details were changed, the previous values were overwritten and business was not able to analyze the historical trends. Then there were data quality inconsistencies. Because the data came from multiple application workflows, there were cases of incomplete payment records or duplicate updates or inconsistent timestamps. So these issues made it difficult to build a reliable dashboard. And lastly, there was there were lack of scalable architecture. Company needed a platform that could grow with the increasing data volume and also support this advanced analytical use cases. So the data engineering team had a solution and they have decided to build this lakehouse architecture using Azure Databricks. So instead of querying the transactional system directly, the data would flow through a structured pipeline using medallion architecture, bronze, silver, and gold. So this pipeline would pull the data from Azure SQL database to Azure Databricks. Then we will perform some cleaning, validations, then we will perform some transformations. Afterwards, we will do some business ready aggregations. And lastly, we will create one BI dashboard in Azure Databricks only. And along with that, we will also set one alert. And then we will utilize Azure Databricks jobs to orchestrate the workflow in which we will have these bronze, silver, and gold work along with BI dashboard and alert. So this is how our project looks like. Now, this is how our architecture looks like. So this architecture, it consists of several components and the layers that will work together. So the first layer would be obviously source system and which is Azure SQL Database. So this Azure SQL Database, it acts as an operational source system for our platform and it stores the transactional business data such as customer orders, product details, and the payment transactions generated by our e-commerce platform. Since our operational databases are optimized for transactions rather than analytics, data is extracted from this system and it needs to be moved into analytics platform to enable large scale processing, historical tracking, and reporting. So for this, next layer comes into scenario, which is data access layer. For this, we are going to utilize Lakehouse Federation. which is used to securely connect our Azure SQL database with Databricks through Unity Catalog without directly replicating or exposing source system. So this connection, it allows Databricks to access the source table in a governed manner and ingest the data or pull the data into Lakehouse platform. It ensures centralized data governance, access control, and lineage tracking while simplifying data pulling process. So we can say that it also provides secure access to Azure SQL database through Unity catalog connections. And this allows Databricks to read the data directly from source without any manual data movement. Then the next layer comes into scenario, which is processing layer. For this, we are going to use Azure Databricks platform. Okay. So this platform or this Azure Databricks serves as a core processing engine for our platform by providing scalable distributed compute powered by Apache Spark. It also performs large-scale data processing, transformations, and analytics operations, which are required to convert our raw operational data into structured analytical datasets. This Databricks, it enables efficient processing of our large volumes of data while integrating seamlessly with Delta Lake for storage and with Unity Catalog for data governance. Then the next layer comes into scenario, which is the GitHub integration layer. So GitHub is integrated with Databricks to manage the version control of the notebooks and the project code. So by connecting this GitHub with our Databricks, all the transformation logics, pipelines, and the data processing scripts that are stored and tracked in a centralized repository. This enables collaboration, version tracking, code reviews, and reproducibility, ensuring that the project follows modern software engineering and data engineering best practices. Then the next layer would be project code layer, which is nothing but our Databricks repos. So these repos contain actual data engineering logic, which is implemented through Python notebooks. So these notebooks implement the medallion architecture which is bronze, silver, and gold. That is nothing but data cleaning, data transformations, and aggregations. This layer acts as a development workspace where data pipelines are designed, tested, and maintained. Okay. Then if we come under this Databricks repos, we have bronze layer. This bronze layer is responsible for ingesting raw data from the source system into Delta Lake with minimal transformations. Then this data is loaded incrementally to capture new or updated records from the source system. This layer will preserve the original structure of a source data, ensuring traceability and enabling recovery or reprocessing if needed. Then the next layer which we have is silver layer, which is nothing but data cleaning and data transformation. It will process bronze data to produce cleaned, standardized, and structured datasets. During this stage, data quality rules will be applied, invalid records are handled, and schemas are standardized. This layer prepares the data for downstream analytics by ensuring it is reliable, consistent, and suitable for business analysis. Next layer would be gold layer, which is nothing but business aggregations layer. So this will generate business ready datasets optimized for analytics and reporting. At this stage, datasets from multiple tables are joined, enriched, and transformed to create aggregated tables that represent key business matrices. Additionally, we can apply the logic of SCD type 2. We can have historical track for this historical tracking. Then we can have business aggregation that will be applied to support analytical workloads and this historical insights. Then the next layer is consumption layer, in which we will build BI dashboards. So these BI dashboards provide visual analytics and reporting capabilities on top of this curated gold datasets. So these dashboards enable business stakeholders to monitor matrices such as sales trends or, for example, payment performance or product category analytics and so on. By querying these optimized goal tables, dashboards deliver fast, reliable insights that supports data-driven decision making. Then the next layer would be monitoring layer, in which we will utilize Databricks alerts. So these Databricks alerts trigger the notification when business matrices cross some defined threshold. Okay. This alerting mechanism, it basically monitors key matrices and the conditions generated from the dashboards or the processing pipelines. When these predefined thresholds or conditions are met, the system triggers notification to relevant person. It would be a business person or stakeholders. And this allows the team to quickly identify the issues or anomalies or important business events by enabling proactive operational monitoring. Then the next layer is engineering workflow. We can also call it as pipeline orchestration layer, in which we will utilize Azure Databricks jobs. So this Databricks jobs, it will basically orchestrate our workflow, and they will schedule and manage the sequential execution of our pipeline. Okay. So our pipeline is going to have notebooks. We will have three Python notebooks. So those notebooks plus BI dashboard plus alert, that will be orchestrated with Azure Databricks jobs. Okay. So this is how our project will have 11 layers. And now we will see how our data will flow through these layers. Okay. Here, there is one note that Lakehouse Federation is not ingestion. So this Lakehouse Federation, it is a query federation, or we can say a push down, and it is not a load mechanism. Okay. So federation, it will act as a connector to read the data from Azure SQL into Azure Databricks. And for our project sake, we are going to pull that data, and then we are going to save that data into Delta tables. So for example, if we are running the pipeline on a daily basis and going forward, if any issue occurs, then we need to trace back our raw data. Okay. So if we'll save that raw data into Delta tables under this bronze folder or bronze layer, then it will be easier for us to analyze the issue, and accordingly we can trace it further. Okay. So for that sake, we are going to save our data under this bronze logic. Let's say that our job runs on a daily basis. Okay. So for today's date, I have 500 records. Those would be maybe all completely newly inserted or updated records. Okay. So we have implemented our logic under these notebook files, following this medallion architecture under this Databricks repos. So under that logic, we will be able to access those 500 records using Databricks Lakehouse Federation. And for our project sake, to maintain the historical data or to track the historical changes, if in case needed, if any issue occurs further, for that sake, we will store our data under this bronze layer. Then we will perform data cleaning and transformations, data joinings, data enrichment. If we have any updated data, then under this manual SCD2 implementation, we will track the history of our records, and then we will perform some business aggregations. So based on this updated data, our BI dashboard will get updated. Once BI dashboard gets updated, we will see if our alert gets triggered or not. Let's say suppose I have a condition that, for example, XYZ needs to be less than 100. If it is equal to or greater than 100, we need to set a trigger, or we need to notify the business or the stakeholders regarding this condition has exceeded 100. Okay. So based on that, we will trigger one notification on one email address. So this is how our project is going to look like. So let's say suppose tomorrow I get 50 new records. Okay. Then our logic that need to perform all this processing only on this newly added record. Okay. So our code will process only new data, which is whose count is 50, but the delta tables which we are creating under these files, right? Those will store 550 records, but in the actual processing, we are going to process only new 50 records. Okay. So let's say suppose right now for our project sake, we have very less data, right? But in your company, you're going to work on millions of records. And if you are receiving millions of records on a daily basis, you can't keep piling up of that data into your jobs. Okay. So let's say suppose you have 50K data, then next day you will have additional 50K data. That means that next day you will again process all 100K data into your pipeline. That doesn't make sense. Then your pipeline is going to crash any day. Okay. So for that, only new records which we will receive, those records need to be processed under our files. Okay. So this is how our project is going to look like. And obviously, while we create these files, we are going to integrate those files under the GitHub so that if you are working in a team, let's say suppose I needed to do certain modifications for any project or for any defect or enhancement, then I'll do those changes, I'll do those modifications, and then I'll push that data on our GitHub, okay? So that other team members who are working on the same project, those will look at those changes and they will pull that changes into their Databricks so that they will keep working on this newly modified files, okay? So that they will be also updated with whatever is happening or whatever changes you have done. For that sake, we have GitHub, okay? So we are obviously, if we do any modifications, then we are going to push those modifications on GitHub. So this is how our project looks like. Now let's move to Azure and try to implement our project on that. Okay, so before moving ahead to Azure, we need to look into our ER diagram too. So this is our e-commerce transactional data model. Here we can see that we have three tables: orders, products, and the payments. Okay, so first table, orders, it will have columns as order ID, customer ID, product ID, then order status, order amount, created at, and updated at. So here order ID will be treated as a primary key, and then product ID will be treated as a foreign key. Okay, so this product ID will be treated as a primary key under the products table. The products table will have product ID as primary key, then product name, category, price, and updated at. So the relationship between products to orders would be 1:many. Then the third table is our payments, where payment ID is our primary key. Then we have order ID as a foreign key here, which is a primary key under the orders table. Then we have payment status, paid amount, and process start date. And here relationship between orders and payments would be 1:many. Okay. So this is how our ER diagram looks like. So till now we have seen how we have seen our project overview, how our architecture looks like, and how our ER diagram looks like. So by implementing all this into our Lakehouse architecture, our company will achieve several benefits. Like first one would be scalable analytics infrastructure, then reliable historical data tracking, then we will have improved data quality, then we will have faster analytical queries, and lastly, we will have automated monitoring for business matrices. Now let's move ahead and look how we can implement our project in Azure. This is my Azure portal. So first things first, you need to have subscription to work on Azure. Okay. So if you have free subscription, then you can opt for that and move ahead. If you don't have any, search for subscriptions here, click on subscriptions, then click on add, give your new subscription name, then add your billing account details here and click on review plus create. So once you click on this, it will take some time and it will create one subscription which you can utilize in your project. Okay. So as of now, I'm going to move ahead with my existing subscription here. Then once you are done with subscription, the next step would be to create a resource group. So resource group, it will basically act as a logical container to store all of your services all together at one place. Okay. So here search for resource group, click on resource groups. So as of now, I already have one resource group created, which I'm going to utilize, but I'll show you how to create a new one. Okay. So here click on create. It will show your subscription name here, add your new resource group name here. Select your region, whichever is working for you or the nearest one, and then click on review plus create. Once you will click on this, it will create a new resource group for you. Okay. And you can store all of your services which are required for this project under that resource group. As of now, I'm going to move ahead with my existing resource group here. So here, just don't pay attention on all of these services which I have created. So under this, we are going to create all of our services newly, okay? So click on create. So first thing, we need to create one SQL database, okay? So for this, in the marketplace, search for SQL database. So this second one, we will click on this, click on create. Okay, so it will cost you some amount here, but you can apply offer so that it will be reduced to 0 USD for 30 days. Okay, so coming down, we will have subscription here, resource group here, which we have already created. If you want to create a new resource group, you can click on create, and from here also you can create a new resource group. Okay, so now here we need to give a database name. Okay, so right now for our for our project, let's say I'll give name as Data to Crunch Novacart project DB. Okay, so this would be my Azure SQL database name. SQL Server, it is showing me one SQL Server which I already have in my resource group. Okay, but we will create a new server here. So for this, I'll click on create. Server name would be maybe, let's say, Data to Crunch Novacart project server. Location, East US is not supporting my server. So let's say suppose I'll select Canada Central, which is nearest to me. Then authentication method, I'll opt for the second one, use both SQL and Microsoft Intra ID. Admin, it will show my email address as admin here. If it is not displaying anything for you, then click on set admin, select your email address here and click on select. Okay. If you don't have anything here under set Microsoft Intra ID. Okay. So now next would be we need to set admin login and password. Okay. And you need to remember that because we are going to utilize those coming forward in our project. So let's say I'll name it as Novacart admin. Okay. And I'll set one password here. Okay. Now click on OK. So now it will show me the new SQL server which I have created just now. Okay. Make sure that you are selecting that and moving ahead with the same one. Okay. Under the compute and storage, you can configure the database if needed. As of now, nothing is needed. So I'll just keep the things as it is and click on apply. Make sure that it is charging you nothing here under the overall billing. Okay. Otherwise, it will cost you a lot of amount. For that, utilize this offer. Click on networking. Connectivity method, you can click on no access as of now. Rest of the things keep as it is. Security, enable Microsoft Defender. I don't need it in my project, so I'll keep it as it is. Additional settings. If you want any sample data which this SQL database provides, which I think that is of Adventure Works. If you want that, click on sample. So it will give you all the tables which are stored under this, which are stored as a sample here. But we don't need anything here because we are going to create new tables here. So for that, I'll keep it as none. Tags, nothing is needed. Review plus create. Make sure that storage cost, it is giving you 0 USD. Check all the details which we have entered here and then click on create. So it will take some time to create this Azure SQL database along with the SQL server which we have created in the first step. Okay. So the deployment is in progress as of now. Our deployment is successful. Now here click on the resource group. So if you can see here, this project server, this SQL server and this database which we have created just now. So click on this SQL server We need to click on this security, come under this networking. Under this networking, you need to click on selected networks. And here, under the firewall rules, you need to click on add your client address. Then it will automatically give your IP address here. And click on allow Azure services and resources to access this server and click on save. So you need to enable this setting because Azure SQL Database, it automatically by default blocks all the external connections, okay? And in our case, we are going to build pipeline in our Databricks. So we need permissions to access this Databricks, to access this database from Azure Databricks, okay? And this firewall rule, it will grant those permissions, okay? So for that, we need to make this change. Otherwise, you won't be able to access this Azure database from your Azure Databricks account. So once you're done with this, come back to your resource group and then click on your Azure SQL database. So once you'll click on this, click on query editor, enter your login and password here, and click on OK. You have another option to log in with Intra ID also. So once you'll click on this continue as, you will be able to log in into this database, or you can also prefer SQL Server authentication method. Click on OK. So now, as of now, we have nothing under the tables, views, and stored procedures. So now we will be creating 3 tables here, and then under these 3 tables, we are going to insert some values, okay? Values or the data, you can say. And let's create these tables. Now we are into our Azure SQL database. Here we will be creating our 3 tables named as products, orders, and the payments. Okay. So we will create first table for products. Then our next table would be orders. And then this one would be orders. And then the third one would be for the payments. Okay. I'll click on this and we'll click on run. It will refresh here. Under the tables, we can see that we have 3 tables created: orders, payments, and then products. Then as of now, these tables are empty tables. So now we need to insert few data into this, and we need to make sure that we are entering messy data too into these tables, because moving forward in Azure Databricks, we need to work on data cleaning and data transformation part too. We need to make sure that we have some clean data and some messy data into each of these tables. Okay. So for that, I have this code written here. I'll just select this code and I'll click on run. Now we can see that we have altogether 1050 entries. So to get this data for the table creation and to insert few data into this, just check the description box of this video. Into that, I'll mention one link. In that, you will get both of these codes there. Now we have inserted 1050 entries here. Let's just check how many entries we have. We have 500 entries under the orders table. We'll check how our orders table look like. If we'll see here, we have some lower cases and upper cases here. We have some null values too. We have some NA values here. We have $sign added here. So basically this means that messy data has been entered successfully. Then the next one is payments. We'll see here we have 430 entries for payments. Let's just check how our data looks like. Payments have payment ID, order ID, status, amount, and process stat. If we'll see here, we can see that we have messy data here. Null values too. We have 0 values here. Some invalid entries here. So this means that we have as expected payments table. Now let's move ahead to the products. You can see that we have 120 entries for the products. Now let's see how our data looks like. We have product ID, name, category, price, and updated at. Here we can see some invalid entries. We have normal cases, we have upper cases, we have lower cases. We have invalid data here. here too. So basically this means we have as expected data into all of our three tables. Okay. So now we are done with our section where we have our data stored into our Azure SQL database. Okay. Now the next step would be to create Databricks account. Okay. And this is our SQL database. And then once we create this Databricks account, we will see how we can utilize Lakehouse Federation and then access this data which we have created here into Databricks using this Lakehouse Federation. Okay. So now let's move ahead and check how we can do that. Now I'm back into my resource group which we have created for this project. So as of now, we have created this Azure SQL database and this SQL server. Now the next step would be to create Azure Databricks. So for that, click on Create, search for Databricks. This second one we need to click on Create. So this will be our subscription and then the resource group. Then next, we need to assign one workspace name for our Databricks. Okay, so let's say suppose my Databricks name would be Data to Crunch NovaCart ADB. So the region, I'll change it to Central Canada. Workspace type, I'll keep it as hybrid. Then we will give managed resource group name. The name for the same would be Data to Crunch NovaCart Managed ADB. Pricing tier, I'll change it to trial, which will be for 14 days. Okay, it states that serverless compute is not available for this trial. That's fine. Next, networking, encryption, then security, tags, then lastly we will have review plus create. Click on create button. Now we can see that our deployment is in progress. Now the deployment is successful for Azure Databricks. So I'll click on launch workspace. So this is how my Microsoft Azure Databricks look like. Now we need to connect this Databricks to our Git account. Okay. So for that, click on this icon, click on settings. Under the user section, you will have linked accounts. Okay. So I'll just first unlink this. Okay. So this is how you will see your portal. You need to click on add Git credential. Select Git provider as GitHub. Give nickname to your GitHub account. Let's say we will say NovaCart case study. We will click link Git account only. Okay. So if we'll click on this learn more. So here you will get all the steps of how you can connect your Databricks to your Git provider. Okay. So it will state all the steps like click on this icon, then linked accounts, add Git credentials, and so on. So all the steps you can find it over here too. Okay. So once you will click on link. Okay. So in my case, it got connected with GitHub without asking for the sign in because I have done that previously by connecting my previous Databricks to my GitHub accounts. But in your case, what will happen? Once you will click on this link, it will ask you to log in for your Git account. Okay. It will ask you, it will give you one page. In that, add your username and password of your GitHub account. And then you can click on connect. Okay. Once you will click on connect, it will automatically link your GitHub account here. And now you also will be able to see your credentials here under the Git integration. Okay. So now the next step would be we need to configure in GitHub. Okay. So if I'll click on this, it will say you need to install your Databricks. Okay. Then it will ask you options like, do you want to connect this or do you want to install this Databricks for all of your repositories or only to the selected repositories. Okay. So we will be selecting only select repositories. Okay. So as of now, I'm not having any repository which I have created for this project. Okay. So for this, what I'll do, I'll open my GitHub account. Sign into GitHub. So here I'll click on repositories. I'll say new repository. Here I'll give my repository name. Okay. So I'll say Novacart case study. Okay. Under the description, you can add the description if you would like to have for this project. So let's say suppose I'll say we are connecting Azure Databricks to GitHub for the project of Novacart company. Okay. Then you need to choose the visibility. It's up to you if you'd like to have public or private. As of now, I'll say private. I'll add README. Then I'll click on create repository. Okay. So this is my repository for our case study. Then I'll come back to the page where we were trying to install Databricks. Okay. Now under this only select repositories, I'll be able to, okay, for some reason I don't see it here, but let me refresh this page. Okay, now under only select repositories, I can see it now, Novacart case study. Okay, so this repository, for this repository, we will be installing Databricks. Okay, then click on install. So now it will state that verify via email. So it will send one OTP on your email address. You need to enter that OTP here. And then click on verify. So now it says that Databricks was installed on this account. Okay. Here again, it will give you all the information which we have selected earlier for this installation. From here also you have the opportunity to change if you would like to change any repository or if you would like to switch to all repository. Uninstall option is also here and suspend your installation option is also here. Okay. So now this is how my GitHub account looks like with Databricks installation. Okay. So whatever programs or whatever code we will be doing, that will get reflected under this repository. Okay. So now I'll come back to my Azure Databricks account. Now GitHub part is done. Now the next procedure would be to create Databricks repos. Okay. So for that, click on this workspace. Then under the workspace here, we have this repos option. Okay. I'll click on this repos option. I'll create one folder here. So I'll say this would be my folder name. I'll click on create. Now I'll say create repo. Okay, so you can create Git folder also, and then or you can create a repo too. Okay, so Git folder. So now see here, we need to create Git folder here, right, which is recommended by Databricks. We need to give Git repository URL here. Okay, so for that, come back to your GitHub account, click on this code under this code, under this HTTPS, you will get one web URL. Okay, just copy that, come back to Azure Databricks, paste it here, and automatically it will give you Git provider and Git folder name. Okay, and then click on create Git folder. So it will state that it is creating in the background. So now this is my this is how I have connected my Databricks repos to the Git folder. Okay, here we can see that if I'll click on this main, this is the main branch from our GitHub. Okay, so this main branch, we are seeing it here. Okay, you have the opportunity, or you will get that leverage that to create another branch from here too. Okay, so I'll click on this create branch. I'll say maybe data to crunch Nova card case study branch. Okay, and then I'll click on create. So it will create one new branch with this name. And here, if you click on this, you will get the opportunity to see both of the branches. Okay, the first one will be main branch, and then the second one, which we have created for our project. Okay, we don't want to switch it because we will be opting for this branch. So all of your code which you will write, once you will write that code and you will push that code, that will be displayed here. With everything, like if that is a new code, then that will get displayed. If you have modified anything in your code, then that particular part will get highlighted, and that everything will get shown over here on the right hand side. Then you can add GitHub message, and description is option, and then you can click on commit and push. Once you will click on this commit and push, you will be able to see that push over here, and from here under this GitHub account, you need to pull that you need to pull all those changes or the code. Okay, we will see afterwards like how we can push our code. So now coming back here, I'll just as of now close this. Now I'll click on create. Now we need to create 3 notebooks. Okay, so the first one would be, I'll just minimize this as of now. So my first file name as of now, I'll give it as bronze work, let's suppose. Okay, now I need to create 2 more, right? So I'll click on this third icon of Workspace. Then from here, I'll click on these 3 buttons. Then I'll click on create notebook. It will create another notebook under this repo. Let's say suppose I'll give the name as silver work. Okay, and similarly, I'll create for the gold work. So these are my 3 files. Then if you'll see here under the catalog, you can see that you have one catalog named as Data to Crunch Novacart ADB. Okay, so nowadays Databricks has started giving us one by default catalog, which will be exactly named as the name which we have given to our Databricks workspace. So if you would like to continue with this catalog, you can go for that. If you would like to create another catalog, you can do that too. Okay, so it's up to you. As of now, I'm going to opt for this default one, and I'll just close this silver and gold. Now I think I have given wrong name. Okay, so now we will start writing our code here, and if you'll see here that branch, right, it will get displayed here too. Okay, so now let's start with our work. Now to access the data from Azure SQL Database to Azure Databricks, we need to create one connection using Lakehouse Federation. Okay, so for that, to create that, click on catalog. Under this catalog, it will see connect option here. Then you need to click on connect connections. Okay, to access external systems. Click on connections. So these are the connections which I have created earlier in other Databricks. So here, in your case, this will not be present here. Okay, this will be blank. You need to create connection brand new. So click on this create connection. So here you need to give your connection name. Okay, so give your connection name here. So this would be my connection name. Then you need to select connection type. Okay, so under here type SQL Server, select this SQL Server. Then it will ask you for authentication type. Okay, so here we are going to select user and password. Click on next. Then we need to give host name here. Okay, host name, port, username, and password. So to get this host name, come back to your SQL Server. Under this resource group, click on this SQL Server which you need to connect. So if you'll see here, this server name, right? We need to give this server name over there. So copy to clipboard, come back to your authentication, paste it here. So this 1433 port, that will be by default given by the Databricks for the foreign SQL Server instances. Okay, and username and ID password, again come back to SQL Server, server admin, it will be your user ID. Just copy this, give this here under the users section, and the password which you have set for this SQL Server, you need to enter that password here. Okay, and click on next. Application intent, you can select read only or read write, whichever you want. As of now in this project we are not going to write anything, but anyways we can move ahead with read write also. Then click on trust this certificate, and now click on create connection. But before clicking on create connection, make sure that your Azure SQL database is active. Okay, and it has not timed out, because if it will timed out, then here you're gonna get error as it is not able to connect with your server. Okay, so for that, and this error you will see over the time period unless you fetch until you fetch or access that data, right? So for that you need to make sure that this Azure SQL database is active and not timed out. Okay, so coming back to this catalog explorer, click on create connection. The connection is successful. Now we need to give our database name here. Okay, so the database name would be, it will come under this Azure SQL database, this name you need to give as your database name. Okay, so copy this Azure SQL database name, come back to Explorer, paste this under this database, and then click on create catalog. So catalog is successful. Click on grant. I'll say for the all account users, I'll give all the privileges. Okay, as of now for this project, click on grant. Then click on here, you will see your email address by default as the owner, and which is locked. Keep it as it is. Click on next. Key value we don't need to give any. Click on save. Now our connection is successful and established. Now we need to select a compute. By default, the compute would be serverless starter warehouse. Okay, just start and close. So our warehouse has been started. Now here you can see that our data is getting loaded. So under here, if you will come under this DBO, if you click on this, under the tables, you can see all of our 3 tables. Okay, so let's say for example, I'll click on any one of the table. As of now, orders table. Here you can see all the columns, their types. You can add comments, tags. If you want, you can add column masks from here. And if you'll see here, the type would be foreign. Okay, because it has been fetched from SQL Server, which is third-party source. So if we'll come here, so this catalog, okay, so this catalog which Databricks gave us by default, that was by default catalog, right? Default catalog. This catalog, it would be our foreign catalog. If we'll come under this details, if we'll click on this catalog and if we'll come under this details, you can see type would be foreign catalog. Updated at, updated by, created by, what's the catalog ID, all the information you will get it here. The permissions, if you would like to change anything, you can change the permissions from here. Okay, so as of now, where were we? We were under DBO, and these were our tables. I have selected this table. It will give you AI suggested description. You can accept it. by checking if the description given by AI is correct or not. You can edit it too. Then it will click on sample data. So by default, it will show you some of the data, okay? So this is how you can see or you can preview your data from here. You can ask the questions on this sample data too, okay? We have details too. Again, the type would be foreign. We can change our permissions from here. We have policies. Then we have history. As of now, table history is not available. Then we have lineage. As of now, nothing is available because we haven't done any or we haven't performed anything on this, okay? Then we have insights and then quality, okay? For the quality, you will need to enable this, but that is not our concern as of now because of our project limit. So my intent to show this was how we can create a connection and we can establish a connection between our Azure SQL database and Databricks, and this is how we can fetch we can access the data from third party, okay? Now we are going to utilize this data and we will store our data under this bronze work. So now let's move ahead and see how we can perform or how we can ingest this data which we have pulled from third party into our delta tables, but that too in an incremental way, okay? So let's start with our bronze work. So overall for all of these notebooks, the programming would feel a little bit complex, but I'll try my best to make it easier for your understanding. So the first, as I have told you that everything, whatever we will be implementing here, that would be for the incremental loads, okay? So for with this, we need to make sure that after the initial load, all the incremental loads will pull only the new data, okay? So for that sake, we will implement all the logic. So the first thing is that we will import some of the PySpark and Delta helper functions, and then we will set up our catalog and schema, okay? So let's first import our Spark SQL function. So for that, from PySpark.sql import functions as if, okay? Then the next, we need to import delta table because our merge operations are used to upsert the records into our delta tables, okay? So for that, we need to import our delta table. So for that, from delta.tables import delta table, okay? Now the next, it would be we need to import date time, okay, so that we can stamp control tables with the current UTC time, okay? So now here control table I have mentioned because we are going to create one table which will be named as control table, okay? And there we are going to store our watermarks, and watermarks it would be the timestamps, okay? So for that we need to import datetime function. So let's say from datetime import datetime, okay? And then we are going to import UUID, okay? So we need to import this UUID so that every pipeline run gets a unique run ID for the traceability, okay? So for that, we need to import UUID. Once we import all these PySpark and Delta helpers, we will run this first, and then we will set our catalog, and then we'll create our new schema, okay? So for that, now we can see that our files are in Python language and sales are also in Python language. But to use the catalog, I need to use SQL query, okay? So for that, to use SQL query under the Python cell, we need to write spark.sql parenthesis under inverted commas, we will say use catalog, and then our catalog name would be this one, okay? Data to Crunch, Novacart, ADB, okay? So this is how we will set our catalog. Then once we set our catalog, we are going to create schema, okay? Again, To use SQL query under the Python cell, we will say spark.sql, and then parenthesis inverted comma, and then we will say create schema. If not exists, and our schema name, let's say it would be bronze schema. Okay, and then we will run this cell. So once you will run this, we will refresh the catalog, and then under this catalog we can see that our bronze schema has been created. Okay, so as of now we don't have any data under the schema, but our schema has been created successfully. So now the next step would be to create this bronze control table. Okay, so this table will store the watermarks for each of the source table, and it helps the pipeline to remember what is the latest timestamp which already processed, then the latest primary key processed at that timestamp, and then how many rows were written in that latest run. Okay, so this is what, or this function will, this logic will make our bronze load incremental and rerun safe. Okay, so now our step 2 would be to create this bronze control table. So for this, again, I'll write spark.sql because we will execute SQL query. Okay. Now I need to use multiple lines here. Okay. So for that, what we need to do under this parenthesis, once you will give this parenthesis, we need to give this 3 inverted commas. Okay. And under this 3 inverted commas, we will be writing our code. Okay. So this basically indicates that my SQL code, which we are executing under this Spark SQL, has multiple lines in it. Okay. So this is the meaning of this triple inverted commas. So for this, I'll say create table if not exists. And then we need to give our table name here. Okay. So my table name would be ingestion control. Again, here I'll have parenthesis, and in this we will give all of our column names. So my first column name would be layer, whether it is bronze, silver, or gold. Then the next column of mine would be table name, okay, with data type string. Then I'll have column as ts call with string. That would be that this column would be for timestamp, okay. Then pk call string. This would be for primary key. Then latest successful timestamp. So this ts call and pk call, that would be the current ones, and then the latest successful ts. This timestamp would be the the latest successful timestamp which we have run. Okay, it is not latest, this is last. So the last timestamp that will get stored here. Then I have last successful primary key. I'll give type as big int. Then I'll have last run id with type string. Then we will show how many rows are written. Maybe big int. Then what's the run status? And then I'll have updated at, okay. Type would be timestamp. And I'll use this, this table name would, this table type would be delta. Okay, so this should create our new table as ingestion control, okay, under this bronze schema. So now let's try to run this. It is successful. Just refresh your catalog. Okay. Okay, so here I need to follow three naming convention. So here I'll click on copy schema path and I'll paste it here. Dot. Okay, so catalog name dot schema name dot table name. Now let's try to run this. It is successful. So now our catalog is getting refreshed. So now under the bronze schema, we can see our table ingestion control. Okay. So if we'll click on this, we can see all the column names which we have created or given here. Okay. So now our second step is done where we created our bronze control table. Then the next step would be source table configuration. Okay. So here or this cell will define which source tables will be loaded into bronze and which columns should be used at. Okay. So for that, our main 2 points will be primary key and timestamp. Okay. And it will also create your unique bronze run ID for your current pipeline run. Okay. So for this, what we will do, we will define source table configuration for each table. Okay. And we will store its primary key and incremental timestamp column for each of the table. Okay. So for that, what we will do, we will say tables config, then curly braces. Here, first table would be our orders table. Okay. So for the order table, again, our primary key column would be order ID, and timestamp column we will refer, that would be updated at. Then comma, again our next table would be products table. For the products table, our primary key column name would be product ID, and timestamp column name which we are going to refer here, that would be updated at. Okay. For this I need to get double inverted. Okay. Now our third and last table name would be payments, and under the payments, we are going to refer primary column name as payment ID, and TS column name, it would be processed at. Okay. So if I'll come back to our Azure SQL database, I'll just relog in it. So I'm into Azure SQL database. So if you'll see under the tables, orders, payments, and DBO products. Okay. So here this primary key column set which we have given order ID, product ID, and payment ID, those it would be these ones. Okay. So for orders we have primary key as order ID, then payment ID, and then product ID. And then the next TS column names which we have given updated at, and for the payments we have given it as processed at. Okay. So those column names, those were these ones. For the orders it was updated at, for the payments it was processed at, and for the products it is again updated at. Okay. So these column names we have given it here for our table source table configuration. Okay. So now once we give this, we need to create a unique run ID for our current bronze execution, right? So for that, what we can say, let's say suppose bronze run ID is equal to, we need it in string format. For that, we have imported UUID dot UUID4. And then once we are done with this, for our sake of understanding, we will print this current bronze ID, run ID. Okay, so we can say that print current bronze run ID dot, and then comma this bronze run ID variable. Okay, and now we will run this cell. Now the next step would be to create helper functions. So in this we are going to create two reusable functions. So first one would be get last successful watermark, and then the second one would be upsert bronze control. So first one, it will read the last successfully processed checkpoint. We can also call it as watermark. And the second one, it will save the new checkpoint after the current successful run finishes. Okay. So for that, if we say like, why do we need this? So we can say that because on the next run, we don't want to load the full source table again. We just want to load the rows that are new since the last successful bronze run. So for that, let's just create first one. So for this, it would be get last successful, just a minute, watermark. In this, we will pass table name as string because we have three table names. So this helper function, this is going to read our old checkpoint. Okay. So in this, we will read our bronze control table as a Spark data frame, and this table contains the metadata of our previous bronze runs. Okay. So to read that, we'll say spark dot table, and we need to read this table. Okay. Now, once we read this table, we need to filter it out. We need to filter some rows that belongs to bronze layer, then the current table name that is passed to the function, and we need to run our we need to check only successful runs. Okay. So this will make sure that we do not accidentally use failed runs as a watermark. So for that sake, we are going to use filter function. So in this filter function, first column would be layer. We need to make sure that we are referring to bronze layer only. Then and condition. Then the next column which we will refer would be table name. We need to make sure that we are referring the correct table. And then we need to check run status. And that needs to be success. We are referring columns from here, okay, from the ingestion control. So once we filter it out, then we need to sort it, okay. So for that, we are going to use order by, and we will refer the column which is updated at in a descending manner. So here we need to sort it out because we need to make sure that we are matching the rows by update time in a descending order. So the newest successful control record comes first. For that sake, we are going to limit it by 1. Okay, so it will keep the most recent record. Okay. Afterwards, we need to collect these rows, okay? For that, we will say rows is equal to ctrl and collect function. So after this, right, we need to bring this limit one row, that one row which will come from this result from Spark into our Python memory. So after this, our rows will contain, these rows will contain either 0 rows or 1 row. Okay, so if it has 0 rows, that means that this table was never processed before. And if it has 1 row, that means that that 1 row is our latest successful checkpoint. Okay, so for this, what we will do, we will use first if condition. If not rows, this means that if no control row exists, it means this is probably the first run. So we need to return none value to tell the pipeline that there is no old watermark yet. For that sake, we are writing this if function. For this, we are going to return none value. And if it has 1 row, then we are going to write, we will directly return the value as. Now what we need to return? We need to return the last successful timestamp and the primary key, okay? So these two together will form the bronze incremental watermark, okay? So for that, first we will return the latest successful timestamp. And then we are also going to return latest successful primary key altogether. That would create our bronze incremental watermark, okay? So this is how our logic looks like for this function, reusable function, which we have created for get last successful watermark. Now it seems that we have some error in this. So let's just run this and check what's the error. Okay, these are some tab issues. So let's just accept the error, accept the changes suggested by Databricks and run it again. Okay, the run is successful. So those were just tab changes, which I haven't done here. Okay, so now our first function is ready. Now we need to create another function. So that function name would be def upsert bronze control. So this helper function, it will update the bronze control table after a successful run. In other words, we can say that once this bronze finishes loading the data, we will save the next checkpoint here. Okay, so the next run knows exactly where to continue from. So for that sake, we are writing this function. So here we are going to pass table name, TS column, then primary column, last successful TS. Okay, we don't need last successful TS. Let's just write it manually. Table name, then we need to pass TS column, primary key column, then we need to pass last timestamp, last primary key, number of rows written, and then run ID. Now we need to create one row Spark data frame which will contain the latest bronze metadata of our current table. So this row will either update the existing control record or it will insert the new one if it does not exist yet. Okay. So for that, let's just create one data frame named as control df. We'll say spark dot create data frame. And then let's just create one data frame here. So our data frame layer name would be bronze. Then we will pass table name, TS column, primary key column, last TS, last primary key, run ID, rows return. We need to pass success as a, we need to make sure that we are only reading successful runs. And then we need to we need to pass current UTC time. Okay. So here what we will do, this last primary key, we will convert it into int. If last pk is not none, else we will pass none. And rows return also, we will change it to int. And date time, we will pass it as UTC now, because current UTC time we need to check when control row is updated. Then once we are done with this, we need to pass schema. So we will write that schema. To write SQL into multiple lines, we have these 3 inverted commas, and then we will pass layer as string, then table name as string, TS column as string, PK column as string, last successful TS as timestamp, successful PK as bigint, last run ID as string, rows return as bigint, run status as string, and updated as timestamp. Okay. So once we are done with this, then we need to open our bronze control table as a delta table. Okay. So we use this delta table because we want to do a merging or upsert. We are not going to append one new row at a time. Okay. So to perform this merge, we need to open this control table as a delta table. So for that sake, what we will do, we'll say dt is equal to then delta table dot for name. Then we will say spark, comma, and then we need to pass that table name. So we will pass that table name here. And now once we read this, we will start merge operation. Okay. So for that, what we will do, we'll say dt dot alias as t. So this T would be our target table. That means existing control table. And we are going to also refer S. That would be source row. Okay. So the new metadata row we just created. Okay. And we will have matching condition. So for that sake, we are going to write this function. So matching condition would be same layer plus same table name. So this means that each source table, it would be either orders, products, or payments that keeps one latest control row. Okay. So for that, let's just perform merging dot merge. For that sake, we will use control df alias as s, and then we need to write our condition. Okay, which I have just told you, same layer plus same table name. So for that, what we will do, this query we need to write it as. Okay. So TS table name table name of target table should match to source table, and layer of target table needs to match with source. Okay. And then if matching row already exists, then we are going to update. Okay. So for this, what we will do, we'll not update everything. We'll just say dot when matched update. Then we will set particular rows. So for that sake, we are going to set TS column as source TS column, primary key from source primary key, and every information from source table we are going to merge it. Okay. So for this, we are going to write it as dot when matched update, and then we will set this condition. And then when not when if no row exists yet in this table, then we will insert the new metadata row as the first control entry. So for that sake, we will write it as when not matched, then insert all, and then execute it. That means that execute that particular merge operation. Okay. So this is how we need to write this upsert function. Now let's just run this. Okay, this run is successful. Now the next step is to create this bronze incremental load loop. So this is going to be our main bronze logic. Here for each table, we are going to read the last watermark. Then we will read the source SQL table, then filters only new or changed rows and adds from the bronze audit columns, then appends the row into bronze delta table, and lastly we will update the control table. Okay, so this is going to be our core logic. So for this, first we will use for loop. So this for loop, it will loop through each configured source table. So the same bronze logic can run for orders, products, and the payments. Okay. So for that, we will pass table name and then configuration CFG in from the tables config, okay, which we have set earlier into this bronze work. Here dot items. Then we will pick the primary key column name for the current table. Okay. So to read that, we will have pk column is equal to from the configuration table. We will read pk call. Then same we will read also ts column also here. So this would be, we will pick the timestamp column used for incremental loading in the current table. Okay. Now we need to build our source table, which would be SQL Server source table, which will refer to foreign catalog source table. So for that, what we will say, source table is equal to f into double inverted commas and then the tick. And here we need to give that reference. So here if you'll see, this one was our foreign catalog. In this we were having TBO. This TBO we need to refer, okay? So for this what I'll do, I'll just copy this schema path and then dot respective table name will pass here so that we can read the correct table from here in a dynamic way. So that one tick we need to complete it here, okay? This will be our source table. Then we need to declare our target table. So we need to build this bronze destination table name where row history will be appended. So for that, we are going to read this under this bronze schema, and our table name would be dynamic table name, either from orders, products, or payments. So this is how, and one more thing we can do, we can say dynamic table name followed by raw. So our table names would be orders underscore raw, products underscore raw, and so on. So this will be our target table. Now we need to fetch the previous bronze watermark. So we only load the rows that are new since the last successful run. Okay. So for that, first we will have last successful TS, then last successful PK, and we will get the last successful watermark from that respective table name. Okay, and then we will print some rows here. We'll say print F inverted commas. We'll say we are processing table name, and that table name it will get displayed. Then we are going to display last successful timestamp and primary key. So this would be fine till here. Now we need to read the current source table from the SQL server, and we need to cast the incremental column to timestamp for the accurate comparison. Okay. So for that we will have one data frame as source df park dot read dot table, and then we need to mention our source table, and then dot with column, and the column name would be tscol, comma, then our column would be, then we need to cast our column. Okay, so for that tscol dot cast, we need to cast it as timestamp. Okay, now we are going to write if condition. So if there is no previous watermark, then this will be our first run. Okay, so in that case we need to load full source table. So for that, if last successful TS is none, then okay, here TS is none. Then in this situation, we are going to load full table. Okay, so rows to load would be complete source TF. And if this is not the situation, then that we will write it as else condition. Else rows to load would be from the source df, where we will filter with our newer timestamp. Okay, so for that sake we will filter it using this ts column needs to be greater than last successful ts. Okay, let me just remove this. So here we need to refer lit function f dot lit, and then or condition. In this again we will write condition as f dot column ts column needs to be equal to last successful ts, and primary key column, which we will cast it as long, that needs to be greater than last successful primary key. Then I think I have done some mistake here, but let's just check it again afterwards. Then we need to start enriching the rows with bronze audit columns, so we can trace when and from where they were ingested. Okay, so for that our logic would be rows to load equal to rows to load dot, we need to store exact time when this rows entered the bronze row, bronze layer or work. So for that, we will have with column bronze, we will have ingested at. Here we will have first as ingested at, bronze ingested at. And here we need to mention current timestamp. Then we need to store bronze run ID on every row so that we can trace which run is loaded into it. So for that, it would be bronze run ID. And then we need to mention bronze source table, okay, to store original source table name. So for that, we will say with column bronze source table. For this, we will use applet as source table. Then we need to count, once this rows to load is done, we need to count the incremental rows selected for this run. Okay, so this is the main metric we use to verify incremental behavior. So for that sake, rows count is equal to rows to load dot count, and then we will print it as print we'll print that respective table name, and then we will say rows to load, and then we will display respective rows count. Now, if no new rows are found, then we need to update the control metadata and skip the write step. Okay, so this is unnecessary as of now. So for that, once we are done with this rows, okay, I have removed this print also. We need to remove these two rows. Okay, so once we print it, then if rows count is equal to 0, then we will print it as no new rows to load from this table name. Okay, and then we will write the new bronze watermark and the run matrix back into bronze control table. Okay, so for that, after this, we are going to utilize our absurd bronze control function which we created. Okay, so for that, we will pass table name, ts call, pk call, last successful ts, last successful pk, then rows count, bronze run id. Once we are done with this, okay, we forgot continue. And then once we are done with this, we are going to append the new incremental rows into bronze delta table. So for that, we'll say rows to load dot write dot format into delta format we need to write. Then the mode would be append, and then we will say save as table, and the table name would be target table. Then once we are done with this, we need to find the maximum incremental timestamp from the rows loaded into this run. So this becomes the new watermark timestamp. Okay, so for that, what we will do, we'll say max ts rows to load dot aggregation f dot max. So f dot we will use let function to get maximum ts, max ts. Then okay, so here what what is missing is we need to use aggregation function f, and then we need to pick, okay, so we need to pick maximum of ts call, and we will make it as alias as max ts. Dot collect the newest max ts. And then for the rows sharing the same maximum timestamp, we need to pick the highest primary key as a tiebreaker for that watermark. Okay, so that would be max pk is equal to rows to load dot filter f dot call if this ts call, sorry, filter condition if this timestamp column matches the f dot maximum timestamp. Okay, so we need to filter this filter with this condition. Timestamp column needs to match with maximum timestamp. Then aggregation that would be on primary key column. So for that, first we will cast it as long, and then we will make alias of this as max primary key, and then we'll collect the newest or latest primary key to check this condition. Okay, and lastly we are going to write the new bronze watermark and run matrix back into the bronze control table. So for that, again I'm going to use bronze, this upsert bronze control function. I'll have table name here, comma ts column, comma primary key column, max ts, max primary key, rows count, and bronze run id. Okay, so here we are writing the new bronze watermark and run matrix back into our bronze control table using this upsert bronze control function. And then we are printing a row written as rows, wrote, then what that respective rows count, rows to that respective table name. Okay. So before running this, whatever we have written for the step 5, we need to make sure that we are logged in into our Azure SQL database. And if you are not, then make sure to relog in it. So I have logged into my Azure SQL database. So coming back to our Azure Databricks. Now let's just run this cell. Okay, so it is saying it is giving us syntax error as unterminated string literal at line 5. Okay, we have this double inverted commas 2 times. Okay, so run and accept. Okay, so now the run is successful. So I have done few mistakes here. Obviously, one of them was giving incorrect parenthesis and the respective tabs. Apart from that, here it needs to be items. I have given it as item. That one more change we need to do. And then the second one was here. Collect function, and then we need to pick the newest one, right? So here I have done some mistake. This needs to be corrected like this. And once we run this, we will see our output as this. Okay, so we have printed few values here, right? So for example, print wrote this value, or here we have printed table name rows to load. Then here we have printed as processing respective table name, last successful timestamp, and primary key. So those printed rows that will get displayed like this. Okay, so as we have 3 tables, so our function ran 3 times for each of the table. Okay, so stating processing orders, then processing products, processing payments, then their last successful timestamps and primary keys. So this is our first run, right? So obviously our ingestion, our control table that needs to be this ingestion control table that needs to be empty, right? We don't have any previous successfully saved timestamp or primary key. Okay, so for that sake, our if condition ran and it says that okay, previously we don't have any successful timestamp and primary key for each of the table. That means that this run is for full run. Okay, so this is not an incremental run because this is the very first run. So for that sake, it has printed as last successful timestamp and primary key as none for each of these table, and orders rows to load each respective rows. Like for orders, those were 500. For products, those were 120, and payments, those were 430. Okay, so that count is getting displayed correctly, and also it is stating the sentence which we have printed, wrote 500 rows to this table, rows, orders raw, products raw, and payments raw. So these are going to be our bronze tables where we are saving our raw data as it is. Okay, so afterwards we can have step 6, and where we can do quick validation, where we will print the bronze row counts, and we'll display the control table so that we can verify the incremental logic if it is working correctly or not. We'll obviously see going forward how we can how this thing runs. Okay, so for that sake, what we can do, we will say print. First we will print orders bronze count, and then we are going to print spark.sql select count star from orders raw. Okay, and we are going to pick and collect the latest successful primary key and timestamp row. Okay, similarly we will print it for products bronze count, and then for the payments bronze count. Okay, and then lastly we will say display spark table, and we need to display ingestion control table, and we are going to use order by table name. Let's just run this table, this cell first. What mistake we have done here? It seems same only. Let's just accept and run. Okay, so this is how we can have our quick validation where it will display what is our bronze count for each of the each of the table orders, products, and the payments. And this table will display our ingestion control table. So when we will cross verify our incremental loading going forward, here we can see how many rows has been written in that particular load, okay? And what was the run status when it got updated? What was the last primary key in that last successful timestamp? And this is some generic information about each of the table, okay? So this is how we can have quick validation and print whatever is required, okay? So now we are done with our bronze work where we have pulled our data from SQL Server, Azure SQL Database to Azure Databricks using Lakehouse Federation. And after pulling that data, we have used this incremental logic function, and with that we have written new data, newly inserted or updated data into our bronze tables, and those were orders raw, payments raw, and products raw, okay? Along with that, we have created one more control table, that is ingestion control table, so that for the next run it will make sure that we are only running this logic only for the new entries, okay? So once we are done with this logic, now we need to push this data to our GitHub account, okay? So we'll click on this GitHub link or GitHub branch. Once you will click on this, so it will state that whatever is added here, so it states that we have added 3 IPYNB files, but obviously those are empty, silver and gold. We have written logic only for bronze work. It will show green means whatever rows are newly added, that will show it in a green. Then we need to add commit message. Let's say we'll say bronze work completed. All the code written is running successful. You can write anything here. Okay, now click on commit and push. So now we will push this code on our GitHub account. Okay, so now we have pushed our code to our GitHub account. I'll go to my GitHub. So if you'll see here, this repository we have created for our case study. We had main branch and this case study branch, which we have created here. In that, we can see we have 3 files here. Now it is asking you to compare and pull the request, okay? So you need to click on this. You can add the title and change the title, whichever you want. Then the description, and you can say create pull request. So once you pull this request, it states that no conflict with base branch, okay? So our code, whatever we have written, there is no conflict with that, okay? So we can say merge pull request. Click on confirm merge. So now our merge has been successful from GitHub end, okay? So now we'll come back to bronze work. We'll close this. And now we need to start with our silver work, okay? So till now we have ingested our data into bronze work. Now we need to start with our silver work. Now with the step 1, we will import all the required functions here. So we will import SQL function, then we will import window class, then delta tables, date time, and lastly we will import UUID, so that we will get run ID for each of our pipeline run, and it would make traceability easier. So once we run this and import all the required functions, then we will use the catalog and create the schema under that, okay? So now, as of now, we have bronze schema. Similarly, we will create silver schema. So for this, what we will do, we'll say spark.sql use catalog, and our catalog name would be Data to Crunch, Nova, ADB. Then under this catalog, we are going to create the schema, okay, silver schema. Then we'll say create schema. If not exists, and name for the schema would be, let's say, silver schema. So once we create this schema, what we will do, we'll just print our run ID, okay? So to do that, what we'll do, we'll have one variable here, silver underscore run underscore ID. And here into string format, we will fetch our respective UUID. And then we will print it as current silver run ID. And we will pass that respective variable as silver run ID. Okay. Now we will run this cell. So we can see that here, this is our current run ID. Now the next step would be to create silver control table, same like we have created for bronze control table. And this table will store the latest silver processing state for each of the entity, which will help us to track the latest bronze run ID, which latest bronze run already processed by silver. Then the latest bronze ingestion timestamp, which is already processed, and how many rows were merged in the latest silver run. Okay. So to create this control table, we will say spark.sql. Then create table if not exists. And we are going to create this table under this silver schema, okay? And our table name, let's say give it as processing control. Then we are going to pass layer name. Then entity name, add string, last processed bronze run ID as string. Then we will have last processed bronze ingested at as timestamp. Then we'll check how many rows has been merged with begint. Then we need to check run status, add string. Then we need to check silver run ID, add string. And then lastly, we will have updated at column as a timestamp, okay? And we are going to create this as a delta table. Now let's just create this table first. So it is successful. We'll refresh our catalog. You can see that now we have this silver schema. Under this silver schema, we have this processing control table with all the written column names which we have given here, okay? So this was our second step to create silver control table. Now the next step, that would be third step, would be to create helper functions. Here we are going to create 4 helper functions. So these helper functions are the main reusable building blocks for our silver layer. So in this silver layer, our goal is not just to load the raw data, but also we want to take only new bronze rows that silver layer has not processed yet. Then we need to clean and validate those rows. Then we need to merge them into silver current state table. And lastly, we need to update our silver control table so the new silver run knows where to continue. Okay. So in simple words, these four functions. So first function, it will write the cleaned and validated data into silver table. Second function, it will read the silver's last consumed bronze watermark. Then the third one, it would save the silver's new watermark after a successful run. And the last function, it will fetch only new bronze rows for the silver processing. Okay. So to create this, first let's start with upsert to silver function creation. So we will write it as definition upsert to silver. Here we are going to pass variables as df source, comma, then we will have another variable as target table, and then we'll have another variable as join key. Okay. So this helper function, it will perform, it is used so that silver table behaves like a current state table. Okay. So if the business key already exists, then we are going to update that row using this join key variable. And then if it does not exist, that means that that business key is new and we need to insert that key. Okay. So for that, under this function, we will use if condition. Okay. Because first we need to check whether the silver table already whether the silver target table already exists or not. Okay. So if spark dot catalog dot table exists, here we will pass our target variable. Okay. Target table variable. Then if it exists, then we will open the existing target table as a delta table so that we can use merge logic there. Okay. So for that, again, we will use dt equal to then delta table for name spark comma table name sorry spark comma target table. Once we open this table as delta table, we will start merging now. Okay. So for that, we'll say dt dot alias target. So here once we start this merging, right? So target will be our existing silver table, and we will use alias as source also. That will be new cleaned and validated data coming in this run. Okay. And in this, we need to check the match rows using business keys. Okay. So for order table, the business key would be order ID. For product, it would be product ID, and for payments, it would be payment ID. Okay. So here we will start merging as dot merge df source alias as source comma and then target dot join key, and that needs to be matched with source join key. Okay. If the business key already exists, then we are going to update first. Okay. So for that, it needs to be when matched, then update all. And if business key does not exist, Then we need to use dot when not matched. It need first this needs to be when matched, and then okay, here it needs to be merged. When matched, then update all. When not matched, then insert all, and then this then execute this function. Okay, so this is gonna be our if condition. Else, in this else block, if the target table does not exist yet, then this is likely to be your first silver run for that entity. Okay, so in this case, we need to simply write the incoming data frame as a new delta table. Okay, so in this case, we'll say write df source dot write dot in the format of delta and save as table, and that would be target table. Okay, so this is going to be our first helper function upsert to silver. Okay, so let's just run this logic first. Okay, so this is successful. Now we are going to create our another helper function, and that one was get last processed bronze ingested at. Okay, so that would be def get last processed bronze ingested at, and we are having entity name as string. So this helper function, it will return the latest bronze ingestion timestamp, which is already consumed by silver, okay, for one entity such as, or any one of the entities such as like orders, products, or the payments. And we need this because silver table should not process the same bronze rows again and again. It should only process the bronze rows that arrived after the last successful silver run, okay. So for that, first we will read our Spark silver control table, which stores our processing metadata for the silver runs. Okay, so that would be Spark dot table, and we need to read this table here. Okay, once we read it, then we need to keep only rows for silver layer, then the current entity that is being processed, and the successful runs. Okay, so for that we need to apply filter condition for this. Okay, so for this dot filter, and this filter condition would go for 3 columns. So the first column would be our layer column. This layer needs to be silver, then entity name, and with this and condition we have one more column to go, which is run status. That needs to be success. Once we are done with this, after filter we need to use sort. Okay, sort by control table, so the newest successful entry comes first. Okay, so for that we will use order by, and the column name would be updated at in a descending order, and we will take very first row, that would be our latest entry. Okay, so once we are done with this, we need to bring this result from Spark into Python. So to bring that result, we will say rows. From the control we will collect those rows. If We'll apply if condition, if not rows, then return null. Else, this means that if no row exists, then it means Silver has never processed this entity before. So return none to indicate that this is our first run, okay? And if this is not our first run, then we are going to return the latest bronze ingestion timestamp, which is already processed by Silver, okay? Rows, latest row of our last processed bronze ingested at. Okay, so this is how our second function looks like. Okay, so I have corrected this indentation, and this is how our code looks like to create this helper function named as get last processed bronze ingested at. Okay, now we need to work on our third helper function, which is upsert silver control. Okay, so it will this helper function, it will update the silver control table after the successful silver runs. Okay, in simple words, we can say that once silver finishes processing new bronze rows, we need to save this metadata so the next silver run knows where to continue from. Okay, so for that sake, we are writing this silver next helper function. So our helper function name is upsert silver control, and then we need to pass entity name, comma, last processed bronze run ID, then last processed bronze ingested at, and then rows merged. In this helper function, we will build a one row data frame which will contain the latest silver processing metadata. Okay, so this row will either update the existing control record or it will create a new one. Okay, so for that data frame, we will write it as control df is equal to spark dot create data frame, and in this data frame we will pass layer name, entity name, last processed bronze run ID, ingested at, rows merged. We will convert these rows merged into int. Then success, we need to mark this run as success. Then we need to pass silver run ID, and then we need to pass date time, okay? The current UTC time, which will be needed for the audit. And once we finish it, we need to pass our schema here. Schema would be layer as string, entity name, last processed, then rows merged, run status, silver run ID, and then lastly updated at as timestamp. Okay. Once we are done with this, we need to open our silver control table as delta table. Okay, so that we can perform upsert function there. So for that, we'll say dt equal to delta table we need to use for name, and then we need to pass our table name, okay, which is processing control under silver schema. Then we need to, let me just clear this. After this, we need to merge a new metadata row into our control table, right? And the matching condition would be same layer plus same entity name, okay? So this will ensure that each entity keeps keeps the latest control record for that, okay? So the logic for that would be dt.alias. We'll keep the alias as t here. Dot merge function, control df. We'll use alias for this as s. And then we will have two conditions joined with and, okay? So the first condition would be for t dot layer. Layer needs to be matched with source layer, and entity name of target needs to be matched with source entity name. Okay. Once we merge this, if the control table rows already exist, then we need to update it. Okay. So when match, then update. Instead of update, we will update it as, with the update we will set those values, okay? So for that, what we can say, set equal to, we need to set last process bronze run ID, then ingested at, then rows merged, run status silver run ID, updated at, okay? And when not matched, then we need to insert all this, and lastly we need to say execute, okay? So this is how our another helper function looks like, which is upsert silver control. Now let's try to run this function. So this is successful. Now we need to write our fourth helper function, okay? That will read the bronze table and it will keep only the rows that silver has not processed yet, okay? So this is the main silver incremental reader, and it uses the bronze ingestion timestamp as a silver watermark, okay? So this function name would be get incremental bronze. Here we will pass bronze table, comma, entity name. And now we are going to read the latest bronze ingestion timestamp, which is already processed by silver, okay? So for that, what we'll say, last ingested at, this would be our variable name, and it will contain the value of get last processed bronze ingested at for that respective entity name, okay? So once we get this, then we need to read this full bronze table for our current entity, okay? So for example, like current entity, it would be either orders raw table, products raw table, or payments raw table from the bronze table, okay? So for that, we will have one data frame as bronze df equal to spark dot read dot table, and it would be our bronze table, okay? So once we read this into our data frame, we will have if condition, okay? So if no previous silver watermark exists, then this is our first silver run. So that silver should process the full bronze table, okay? So for that, if last ingested at is none. Then we need to return bronze df, comma, last ingested at. Else, we don't need to write else here. Else, return. Otherwise, we will return only the bronze rows that arrived after the last bronze ingestion timestamp already consumed by the silver. Okay. So this would be otherwise return bronze table. Here we will apply filter condition, and that would be on the column bronze ingested at, that needs to be greater than the last ingested at. Okay. Let's just try to run this first. Now our fourth helper function is ready. Now our next step is step 4, orders incremental processing. Now the next step would be data cleaning and transformation. So the first table we will target, it would be orders table. So here our goal is to read only the new bronze order rows that silver has not processed yet. Then we are going to clean and standardize those rows. Afterwards, we will keep only the latest version of each row ID, each order ID, because order ID is our primary key. Then we are going to validate our cleaned data using silver data quality rules. Okay. So this part, it would go under cleaning part, and we will create, once we are done with this, we will create one table under silver schema named as orders cleaned. Okay. After that, we will start with our transformation part. And in this transformation, we will add certain columns in that. And afterwards, we are going to create two different tables for that. Okay. So the first table name would be orders transformed, in which we are going to have good records with which we will process further. And then I'll create another table for bad records. So that table name would be orders quarantine. Okay. And that table or that data, we can forward it to the orders team to cross verify what's the exact issue with those order. Okay. And that particular team can backtrack that issues. And if there are genuine issues, then they can fix it and correct those orders. Okay. So this is how our data cleaning and transformation part looks like for the orders table. So this is our raw data for orders. This is how it looks like. We have customer ID, order ID, customer ID, product ID, status, amount, created at, updated at, bronze ingested at, bronze run ID, and bronze source table. And obviously we know that this is messy data and we need to clean this data first. Okay. So for that, here we will start with our processing. So we need to make sure that we are reading only bronze order rows that silver has not processed yet. Okay. So for that, we will have these two variables, order inc and last orders ingested at. And we are using this helper function here, which is get incremental bronze. So if you remember above, we have created this incremental bronze helper function. And for this, we are passing two variables, which are bronze table and the entity name. Okay. So here our bronze table would be this orders raw and our entity name is orders. Okay. So once we are done with this reading, then we are going to count how many new bronze orders. With this logic, we are going to count how many new bronze order rows are entering this silver layer in this run. Okay. And this will be useful for validation and to prove that pipeline is truly incremental. Okay. For our understanding sake. So for this, we will count this using, and we will store it under this variable orders inc count. And then we are going to print it as orders rows to process in silver, and we will display that count for our sake of understanding. Okay. Then we will continue with this logic only if there are new bronze orders rows, okay? So the order count is 0, then there is nothing new for silver to process, okay? So it will skip this logic. And this logic will continue if we have new rows which are processed under bronze order rows, okay? And that we need to work on for data cleaning and transformation under this silver layer, okay? So for that sake, we have this if statement. Now we are under this if statement, okay? So for under this if statement, we need to create a window specification for order ID, okay? So this will be used to keep only the latest version of each order record, okay? Here sorting logic we will apply. So first we will use updated at, and we will sort it by descending so that we can get the latest business update first, and then bronze ingested at in a descending order, so that if two rows have same updated at, then we will keep the one that was ingested later into the bronze layer, okay? So for that sake, we are creating this window function. Then we will start with our data cleaning part here. First, we are creating this data frame as orders cleaned, and for that we are using this orders inc data frame which we have created earlier, okay? Here. Then we are using this orders inc data frame, and on that we are performing this standardization, this logic. So what we are doing here, so first with column we are using order status, and we are converting and changing this order status to uppercase, and before that we are trimming it, okay? So once we are done with this trimming, we are trimming the extra spaces which we have with this order status, okay? And once we trim that, we will convert those order status into uppercase. Then once we convert that to uppercase, then what we are doing, so if we have, then we are converting our blank order status values into null, okay? So if you have nothing in that column, then we will change it with null value, so that we will capture those null values afterwards into our transformation part, and we can push those entries into our quarantine table, okay? So for that sake, we are converting these blank entries with none values, okay? So next, with this logic, we are removing the formatting symbols for the order amount, right? We have formatting symbols like $sign, or we have commas in between, or we have spaces in that. So these values, we are changing it, and then we are casting it to numeric, okay? So for that sake, we have used this function where we are using regex replace for that, and we are replacing those values with blank, okay? And then for this logic, we are converting known invalid text values into null so that they can be quarantined later, okay? So we have some certain typical values as NA, or we have written null, or we have question marks, or we have some blank spaces, okay? So those values, we are converting all those values into null value, okay? So that we will use those values and we will push those entries into our quarantine table. So once we are done with this logic, then we are converting our order amount into numeric format so that it can be used for the validations and aggregations further. Then created and updated at, we are using proper timestamp type for these two columns. Once we are done with this, then we are assigning row numbers within each order ID group using window logic. Okay, so the newest row gets the row rank as 1. And once we get that newest row, we will keep that row, and the rest of the rows we will drop it. Okay, so for that sake, we will use this drop function because other rows that are no longer needed for us. And then we are adding, we have this silver run ID already, right? Okay, we don't have silver run ID, so we are adding this column as silver run ID, and in that we will add run ID of that particular pipeline, because this will make us easier going forward for the traceability. Okay, so we are adding this new column as silver run ID. So this is how our data cleaning part looks like for our orders raw table. So now once we are done with this data cleaning part, we need to create table, okay, which will be named as orders cleaned under silver schema, okay. So for that we will use upsert to silver function, which we have created above. This first helper function, upsert to silver. This function, upsert to silver, where we need to pass source data frame, then the target table, and what would be the join key for that, okay. So that logic, we are going to use it here. So our data frame is orders cleaned. This data frame, then our table name would be this one, orders cleaned under silver schema, and our join key is going to be our order ID, which is our primary key, okay. So this is how we are going to merge the cleaned or validated silver dataset into delta table, okay. The next one, this logic, now we are done with the cleaning part. Now this logic would be for the transformations, okay. So for this, I have created new data frame as orders validated, and we are going to use already cleaned, already used data frame which we have used for data cleaning, that is orders cleaned. On that data frame, we are going to perform transformation part, okay. So for that, so we have this logic here where we are creating one new column, and the column name would be to be verified by orders team, okay. And this column needs to contain certain values, right? So if in our table, if the customer ID is null, then that table entry under this to be verified by orders team, that table entry needs to be verify customer ID, okay. Then if product ID is null, then we will say that verify product ID. Then if order status is null, or we are using or condition here because sometimes it happens that we need to trim the order status if that is blank. This is for the safety, I have added this or condition again. So for the order status and order amount, first for the order status if it is null, and if in case if it is blank entry, then we will add the column entry as verify order status under this column name, okay. And for the order amount, if the order amount is null, or if the order amount is equal to or less than 0, then that entry would be verify order amount, okay. Otherwise, if everything is perfect, we don't have any null values in these main columns, then that order entry would be no issues, okay, because we don't have any null values, so that doesn't need to be verified by order stream, okay. Then we have one more with column condition where we will add check order amount, okay. So we are creating one more column with the name as check order amount. If the order amount is null or less than equal to 0, then that flag needs to be raised as true, okay. So for under this new column name check order amount, that flag would be true. If we don't have this condition, the order is perfectly right, like it is into positive, then orders, otherwise that check needs to be false, okay. So this condition, this code, it will create one more new column. Under that we will have true or false checks based on this orders amount, okay. Then with this logic, we are creating 5 different columns, okay, based on this created at, okay. So from this created at entry, we will have different order date as a new column. Then we will have order, we will extract order year as a second column. Then we will extract month as a third column. Then that particular day, we will extract it as order day. And let's say suppose I want that days of the week, okay. So for that, I'll create another 5th column. Here we can see that logic, like to date, then to extract particular year, we have this dot year, dot month, For day, we have day of the month, and then we have date format. Okay. So this is how we are going to create 5 different new columns. So now once we are done with this transformation, as I have told you earlier, I'm going to create 2 tables from here. Okay. So this orders good. I'm going to have under this data frame, I'll filter it by to be verified by orders team. Okay. So if this column entry is no issues, that means that we have that data as a good data. Okay. So we are going to keep that data. Otherwise, we are going to push that data into another data frame. Okay. So this data frame, it will contain all good data where to be verified by orders team is marked as no issues. Okay. If that is not marked as no issues, that means that it needs to be verified by orders team for certain condition, maybe order status or order amount or something. So for that, we are going to create this another data frame named as orders bad. Okay. Afterwards, we are going to merge both the data frames, right? So now upsert to silver function I'm going to use. So this will merge the cleaned or validated data set into delta table. Okay. So this data frame orders good, comma, where do you want to merge that data? So that table name would be orders transform and join key would be order ID, which is our primary key. Then for the bad record, we are not going to merge that data, okay? We are going to append those rows because orders team needs to verify that how many times this order has been processed and what's the record for each of that. So for the audit purpose, we are not going to merge it. We need to append a bad record, okay? So for that, we are going to create another table named as orders quarantine, and we are going to append those bad records under that, okay? So this is how this logic for cleaned and transformation looks like. Now, next, going forward from here, we need to find the latest bronze ingestion timestamp for the current incremental batch. Okay. Sorry. Yeah, correct. For the current incremental batch. And silver stores this in control table. So the next run knows where to continue from. Okay. So for that, I have created this variable mx ingested. And that will have or from this orders inc data frame, we will aggregate it, and then we will find out the max ingested at entry, and that entry we are going to have here with this logic. So this will help us to track exactly which bronze silver has consumed. Okay, so this particular, we need to first find this bronze run ID which is associated with the latest bronze ingestion timestamp, and then this logic, it will help us to track exactly which bronze batch silver has been consumed. Okay, so here we will use this logic and we will collect the latest record for this, and then we are going to update our silver control table with the latest processed bronze watermark. Okay, so this will tell the next silver run what bronze run was last consumed, then up to what bronze ingestion timestamp silver has already processed, and lastly how many valid rows were merged into this run. Okay, once for that we are going to call this helper function which we have created above, and then we are going to upsert all those values into our control table. Okay, now we have this else condition. So this else condition is for this if which we have started here. So we have done all of this when we have certain entries into our table, right? If we don't have any entries, then we are going to simply print it as no new records we have from the bronze rows to the silver. Okay, and then we need to use this upsert helper function, upsert silver control, because even if we don't have any orders rows to perform data cleaning and transformation, we still need to update the silver control table So this run is recorded properly. Okay. So in this run, we will say that we have no new bronze run IDs. In this case, we will say that no new bronze run ID is available. Then bronze watermark remains the same, and rows merged that are going to be 0. Okay. So that we need to mark as no rows merged is equal to 0. So for that, this else function, this else part will run, and we are going to call this upsert silver control under this else part. Okay. So now we will run this. So here I'm getting one error because here column name updated as that is not able to resolve, because under the processing control, when I created this table, the column name which needs to be updated at, that is misspelled by me. Okay. So if you see here, that is not correctly spelled. So for this, I need to alter this table with correct column name. For that, I have executed this query, spark.sql, and we are altering this table where we are renaming the column up, incorrect name to updated at. Okay. So I have ran this. Now we will refresh the catalog and we'll check. So now it has been spelled correctly now. Okay. So the error I'm getting here because before recording this video, I already ran this query and I have already altered this column name to updated at. I just didn't refresh it to show you guys, but I reran it again, and now this time they are not able to get this incorrectly spelled name. Okay. So for that sake, this error is getting shown. But if we'll run this query for the first time, it has ran successfully. Okay. So with this, we have updated this column entry correctly. Now I'm going to run this cell which we have created for cleaning and transformation. Okay. So this one, I'll just comment it. So now here we can see that our tables has been created successfully, cleaned, quarantined, and transformed. I'm getting here one warning regarding UTC now. I think they are in the future versions, they are depreciating this date time UTC now. So for that sake, we are just getting this one warning. Otherwise, our code has run successfully. Okay. So now here we will try to check how our data looks like. Okay. Select star from. First, we will check our cleaned orders. So here we can see that this has been trimmed and changed to uppercase, and certain values which were into incorrect format like question mark or NA, so that are replaced with null. Okay. So this seems that order amount is also correctly given, and the values which we don't have, those are marked as null. Okay, because we are going to quarantine it. Rest of the values are getting displayed correctly. Okay, so this means that our cleaning part has worked successfully. Now let's just check transformed table. Here now we can see that these many tables we have already added. Sorry, not tables, columns to be verified by orders team. Then we have created one column, check order amount, then order date, year, month, day, order day of that week. So these columns has been added successfully. And if you see that here, this needs to be no issues and this needs to be false, because this is our correct data, good data. So this needs to be marked as no issues and false. And if it is not marked as no issues or false, then that data we will find it under quarantine table. Okay, so let's just check that. So here we can see that we have certain null values here. So let's say suppose we have order status null here, right? Then this entry needs to be verify order status. Okay. So now for the next entry, we have order amount marked as null. Then for this, our entry would be verify order amount and check order amount status needs to be raised as true. Okay. Similarly, we'll check if we have customer ID null. In this case, our entry would be verify customer ID. Okay. So this means that whatever transformation we have applied for this quarantine table, that is working as expected. Okay. So next, going forward, we are going to perform now data cleaning and data transformation for products table now. Okay. So now let's move ahead with this logic. Now in the next step, we are going to work on products table. In this, we will perform data cleaning and transformation on this products raw table, which is saved under this bronze schema. Okay. So if I'll select this, I'll do select star from on this table, then we can see that we have certain messed up data like product name is blank. Then we have some added blank spaces here. Category, it is not correctly into uppercase, all the data. Then here we can see that instead of dot, we have column, we have commas. Then we have certain spaces at the initial part. Then in certain prices, we have dollar sign added. We have certain invalid records as question mark. So in this way, our data is uncleaned, I say, and now we need to work on this data to make it clean, and we need to do certain transformations. Okay. So in this section, we are going to perform those cleaning and transformations. So here, our goal is mainly to read only new bronze product rows that silver has not processed yet. Then we need to clean and standardize those rows. Afterwards, we keep only the latest version of each product ID. Then we are going to validate the clean data using our silver data quality rules. Once we are done this with data cleaning part, we will save that data as products cleaned under silver schema. Then for the transformations, we are going to add certain columns in the same. And then we are going to split that transformed data into two tables. Okay. One would be for good records, another would be for bad records. Okay. Then we are moving ahead with the good records that will be named as product transformed table. Okay. And the rest of the entries that will come under bad records, and that table name would be products quarantine. And that products quarantine data that will go to the products team to cross verify what's the exact issue that is happening with that respective product. Okay. And then lastly, we are going to update the silver control table. So the next silver run knows where to continue from. Okay. So for that, we are going to read only bronze product rows that silver has not processed yet. Okay. So for that, we are utilizing our helper function, which we have created, and that is get incremental bronze. And this function, it will use the silver control table watermark to fetch only new bronze rows. Okay. So for that product INC, this is the data frame which we are using. And in this data frame, we will store our data, which will come after this processing. Okay. And that we are going to use forward. So this is the table products raw table from which we are going to fetch the new data. Okay. Then here we are taking the count of incremental product rows that are entering into this silver layer in this run. Okay. So that count we are going to store under the variable products inc count. And then we are just printing that count for our sake or for our understanding. Okay. So this printing is completely optional. Even if you can't, even if you don't use it, that's fine. But for our understanding, I have just added so that I'll get to know that, okay, for in this run, I have processed this data, this many data I have added and I have under silver layer, so that if the count mismatches anywhere, then I'll get to know that, okay, this is the problem or that problem is here. I need to check this logic. Then I'm using if condition and I'm going to perform cleaning and transformation only if I have any data which has come into the silver layer from the bronze layer. Okay. So if I don't have any data here, then it doesn't make sense that you are performing cleaning and transformation for no reason. Okay. So for that sake, I have used this if condition here. And else, if I don't have anything here, then else in the else part, we are just going we will not perform any cleaning and transformation, but we will use upsert function and we will add a new entry into our control table. Okay, so that going forward, it will not that particular entry will be needed for the next processing. Okay, so for that sake, we will be having this else function here, else loop here. Okay, here under this if condition, first logic is for window function. Again, I have created one window named as product window, which will be using window specification for product ID, which we are using as partition by. And then we are using sorting logic using order by, and we are sorting it by two column names. Okay. So first column name would be updated at. We are sorting it in descending order. So that we can get latest business update first, and then we are using bronze ingested at in a descending order, so that if two rows have the same updated at for the same product ID, then we are going to keep the one that was ingested later in the bronze table. Okay. Once we are done with this window function, then in this section, we are performing data cleaning part. Okay. So for that, I have created this data frame named as products cleaned. Okay. And we will use this existing data frame, which we have product inc, and we will perform cleaning part on that. Okay. So firstly, we are using with column product name. Here for the product name, firstly, we are trimming the additional spaces for that respective product name. And then we are converting those product names into uppercases. Okay. Then once we have converted into uppercase, then what we are doing, so if we have any blank entries here, okay, so in that case, we are converting those blank product names into null values. Okay, so that data quality checks can catch them properly in the later part for the quarantine table. So for that sake, I have added this with column. Then the next one is for the next with column is for category. For category, each of the category value, first we are firstly we are trimming it, and then we are converting it into uppercase. For some categories, I have like invalid entries, like for electronics, I have this invalid entry. This is like incorrectly spelled. Okay, so we need to change it into properly into electronics. Okay, so for that, I'm saying firstly we are trimming each and every category with the additional blank spaces. Then we are converting it into uppercase. And if I have certain entries like this, then we are changing it into correctly spelled electronics word. Okay, and otherwise we are going to keep those column entries as it is, and we are just going to convert it into uppercase. Okay, so this is how this standardization of category values would work in this section. Then next, with column price, we will start cleaning our price field by trimming the spaces. So this one is to trim the additional spaces for the price field. Then we are removing the symbols. Like if you have any dollar symbol here, then we are removing it. Then if you have commas instead of dot, right, into our price value, like 40, if you have floating value like 40.00. So instead of that, we have certain invalid entries, right? 40 instead of dot, they have given comma. So if we have certain such kinds of values, then we are changing those commas into dot. Okay. Then with column, if with this, what we are doing, if we have any additional spaces from this price string, right, then again we are removing those additional spaces, I can say. And then we are converting these prices. This price we already it was into string, right? Then we are converting it into numeric value. Okay, so try-cast we are using it, and try-cast is safer because invalid values, it become null instead of failing the pipeline. Okay, so for that sake we are using try-cast, and we are converting our string values into numeric values. Then for the updated add, we are converting this updated add into proper timestamp type. With this function, we are assigning row values within each product ID group using the window logic. So the newest row gets the row rank as 1, and then we are going to keep that value which is ranked as 1. Okay, and afterwards we are going to keep only the latest row for each product ID. Okay, so the rest of the rows we are going to drop it. Afterwards, lastly, we are adding one column named as silver run ID, and we are adding current silver run ID on these rows for the easier traceability. Okay, so this is how our data cleaning part works. Then we are using upsert function. With this upsert function, we are adding our cleaned data into this products cleaned table under silver schema. Okay, and here our join key would be primary key, and that is product ID. Okay, so in this way we are merging cleaned or validated data into delta table, and that delta target table would be products cleaned. Okay, now we are done with the cleaning part. Now we'll start with the transformation part. Okay, so for this I'll have new data frame name which is products validated, and the data frame which is already existed here which is products cleaned. I'm going to work on that. Okay, so for that what I'm doing, I have added this logic to add a new column. Okay, so the new column name would be to be verified by products team. So in this case, if product name is null, then we will add that field as verify product name under this to be verified by products team column. If category is null, then we will say verify category. If price is null or price is less than equal to 0, then we will add it as verify the price. And if there is no condition like this, then we will say otherwise no issues. Okay, so if everything is fine, we have product name, we have category, we have correct price, then there is no issue into that. So that would be our good data. Okay, so for that sake we will add that field as no issues. Okay, then with this logic we are adding one more column, check product price. If that price value is null or less than equal to 0, then we will say that we will add that field as invalid price under this check product price column. Otherwise, if price is good to go, then we will add that field as valid price. Okay, so this is how our transformation part would work for products table. Now the next part would be to separate our data, right? So this is the logic where we are going to create two data frames. One would be for products good and one would be for products bad. Okay, so here this is the data frame on which we have performed transformation. So here we will apply one filter. Okay, so here if the column to be verified by product stream is not equal to no issues, or if the check product price column it says that you have invalid price, then we are going to add that entry under products bad data frame. Okay, and similarly I think I have forgotten this part. So for the products good part, we will apply filter if to be verified by product stream has no issues entry, and the check product price column has valid price entry, then we are going to keep that entry under products good data frame. Okay, and if in this condition we have applied one if condition, if the price raw exists from any previous logic or schema versions, then we need to drop it from the final transformed dataset. Okay, so this keeps the silver transform table clean and easier to use. So for that sake, we have added this if condition, and this condition will remove the raw price column because the cleaned price column is enough and good to go, right? So for that, it will just to keep only valid product rows for our transformed silver table, we have just added this if condition, and this condition is to validate bad products data. So once we are done with this categorization or splitting up of the data, then the good products entries we are going to merge it into our products transformed table under silver schema, and here our primary key is product ID, which would be again our join key. Okay, And bad data, we are not going to merge it. Bad data, we are just simply going to append it. Okay, so the format for the same would be delta, mode would be append, and we are going to save that data under products quarantine table. Okay, then we have this logic, mx ingested. So this logic is written here to find the latest bronze ingestion timestamp from the current incremental batch. Okay, so the silver stores this in control tables, so the next run knows where to continue from. So for that sake, this logic has been added. And this one, for this, it will find the bronze run ID associated with the latest bronze ingestion timestamp, and this will help to track exactly which bronze batch silver has consumed in this run. Okay, so for that sake, this logic has been added. And as we know that, okay, now, and we are using upsert silver control function here to update the silver control table with the latest processed bronze watermark. Okay, so that this will tell the next silver run that what bronze run was lastly consumed, then up to what bronze ingestion timestamp silver has already processed, then how many valid rows were merged into this run. Okay, so for that, we are adding this function here. Okay, and which will store that data using this upsert silver control. And this else section, which I have told you earlier, if no new bronze product rows exist, then we are simply printing a message using this print function, print statement. And once we are printing it, but still we need to update the silver control table, so this run is recorded properly. Okay, so in this run, no new bronze run ID is available. Bronze watermark remains the same, and rows merged, it would be equal to 0. So for that, again, we are calling this upsert silver control function, and we are adding these values here. Okay, so this is how this products cleaning and transformation part would work. Now I'll just run this. Okay, so here I have given incorrect catalog name. It needs to be. Okay, now let's try to rerun it. I think I have missed it somewhere. Okay. Here also I need to change catalog name. Now let's try to run it again. Okay, so our run is successful. Again, we are getting this warning for UTC now. That's fine. Let's just refresh the catalog. So you can see that we have these three tables. Now let's try to run this and see if our data is correct or not. We'll say select star from products clean first. Okay, so here after data cleaning and transformation, I have found that there are certain entries of product names which are not cleaned properly, because here underscore needs to be removed here. Apart from that, rest of the things looks good here. So for that sake, I have done one change into our cleaning part. So if I'll come up, so this is the logic I have added. Okay, On the column products name, here if I have underscores, then I'm going to replace it with space. Okay, so with this logic, if I'll run this logic, then my data is getting modified correctly and I'm getting the correct data like this. Okay, so this now our data seems cleaned properly. So for that sake, just add this one row into your logic, which is this one. Okay, now we can see that products clean data. Now let's check another tables which we created for the products. Now let's just check transformed. For the transformed, we can see that we have only no issues and valid price entries present here. And if we'll check the data, we can see that no blank entries we have into this table. Okay. Now let's just check our quarantine table. Okay, here now we can see that we have certain null values. Let's just check if we have null product name. Okay, then it says that verify product name. If we have null price, then it states that verify price, and along with that, check product price, that is also invalid price. Okay, so that this means that our logic which we have implemented under transformation, that is working as expected. Now next we will move ahead with payments table and we will perform data cleaning and transformation part on this last table. For this payments data cleaning and transformation, our goal is very clear. First, we need to read only the new bronze payment rows that silver has not processed yet. Then we need to clean and standardize those rows. Afterwards, we need to keep only the latest version of each payment ID. Afterwards, we will validate the clean data using silver data quality rules. Then we are going to split our data into good records and bad records. And lastly, we are going to update our silver control table. So the next table run knows where to continue from. Okay. So here again, if you see here, firstly, we are reading with this helper function, we are reading only the bronze payment rows that silver has not processed yet. Okay. So this function, it will give the silver control table watermark to fetch only the new bronze rows. Okay, so for that sake, we are using this helper function here. That data that will get fetched into this payment inc data frame. Okay, so this data frame we can utilize further for cleaning and transformation part. Then we are counting the rows if we have any under this data frame, and then we are printing those rows for the understanding sake here using print statement. Then we have this if statement here. If the values are, if the count is greater than 0, then only we are going to perform cleaning and transformation. Else we are just going to update our silver control table. We are not going to perform cleaning and transformation part for this else block. Okay, so under this if statement, again we have created this window function. So this window function, it will this window function we are using to get the latest payment records for each payment ID. Okay, and we are sorting it, we are partitioning it by primary key, which is payment ID, and then we are sorting this using two columns, processed at and ingested at, in a descending way so that we get the latest value. Okay, afterwards we are done with this partitioning. This is where we are performing cleaning part for the payments data. So for that, we are using the payments inc data frame on which we will perform this cleaning part, and the cleaned data set we will store under this payments cleaned data frame. Okay. So here with column payment status, we are standardizing this with payment status column where we are removing blank spaces using trim function, and then we are converting this status into uppercase. Okay. Then if that status is blank, if we don't have any entry there, then we are replacing that blank entry with null value. Okay, so that going forward, we can separate those data for to quarantine it, okay? And then we can maybe cross-verify what's happening exactly for that. So for that sake, we have implemented this code. Then we are performing cleaning part on paid amount column, okay? So with this paid amount, first we are trimming this column and removing extra spaces. Then if we have any dollar sign present in paid amount column, then we are removing that column with blank space, okay? So we are just removing that dollar symbol from our amount string, okay? Then if we have any commas in that, then we are replacing those commas with dot. Afterwards, with this statement, we are removing extra spaces from the amount string. If we have any extra spaces that would have been created under this statement, those will get removed with this statement. Once we are done with this, we are converting this paid amount from string to a numeric value. So try-cast, we are using it for this because it is safer, as invalid values become null instead of failing the pipeline. Okay, so for that sake, we are using this try-cast. Then process stat column, we are converting the type of processed at to a correct timestamp type. Once we are done with that, we are applying this window function here, and we are assigning row numbers with each payment ID group using this window logic, and the newest row, it will get ranked as 1. And then we are filtering out that only newest row, which is marked as 1, and then removing the rest of the entries which are not required. And afterwards, we are adding one more column named as silver run ID, in which we are going to store that respective run ID for each of the entry. So this is how our data cleaning part works. Once we are done with this data cleaning part, we are going to merge that data into our table named as payments cleaned under silver schema. And here joining key is going to be the primary key, which is payment ID for this payments table. So once we store our payments clean data, then we will start with our transformation part. So this is where we have performed transformation. For this, we are using already existing payments cleaned data frame, and we are going to perform transformations on that data frame. And then we are going to store store that transformed table into this data frame, payments validated. Okay. So here we'll see what we are doing exactly here. So with column, we are adding this new column as to be verified by payments team. Here, if order ID is null, then the field value of this column of this table, it would be verify order ID. If the payment status is null, then we will mark that field under this table, under this column to be verified by payment stream as verify the payment status. And if payment amount is null or less than equal to 0, then we will mark it as verify paid amount. If we don't have any of this condition, like we have order ID correct, we have payment status, we have paid amount into positive value, then we will just mark it as no issues. Okay, so this is how we will create one new column using this with column. Again, we are creating one more new column named as check paid amount. Here, if the paid amount is null or paid amount is less than equal to 0, then we will mark that field as true, else we will mark it as false. So if we have any issue with that paid amount, then we will state that field as true. Otherwise, this is going to be false. That means that paid amount is exactly as it is. So once we are done with this, again, as usual, as we have done for the rest of the two columns, we are going to separate out good data and bad data. Okay, so if we have to be verified by payments team field as no issues, then that is our good data. If that payments team field value is not equal to no issues, then we are going to mark it as payments bad data. Okay, And now we are going to merge this code data using upsert to silver function, which we have created. And then we are going to store that data or merge that data into payments transformed table, which will be saved under silver schema. And if we have this bad data, which we have under this payments bad, we are going to append that data into this table, payments quarantine table, which is under this silver schema again. But in this case, we are just going to append the bad data and we are going to merge the good data. So once we are done with this, again we have this logic here. So with this logic, we are going to find the latest bronze ingestion timestamp from the current incremental batch. And silver stores this into control tables so the next run knows where to continue from. And then it will find this bronze run ID associated with this latest run, with this latest bronze ingestion timestamp, and this will help to track exactly which bronze batch silver has consumed. Okay, so with this logic, once we are done with this logic, then we are going to update our silver control table with the latest processed bronze watermark, and this tells the next silver run that what bronze run was lastly consumed, then up to what bronze ingestion timestamps silver has already processed, and how many valid rows were merged in this run. So once we are done with this if logic, so this will be completely for data cleaning and transformation. In the else part, we will just print it as no new bronze payment rows exist. We will print that statement. This is again optional. And even though we don't have any values, we need to still update the silver control table so this run is recorded properly. So in this case, no new bronze run ID is available. Bronze watermark remains the same. And rows merged, it needs to be equal to 0. Now we will run our code. The run is successful. Let's just refresh our catalog. We can see our newly created tables here. So first, let's just verify our clean table first. This is how our clean data looks like. It has been converted to uppercase. Paid amount is getting displayed as it is, as exactly it is. So here you can see that all the entries are 100 because I have inserted data where all the paid amount is 100. So that is not any mistake which we have done under cleaning part. So this is what exactly it was when I inserted the data here. Now let's verify transformed table. So this is how my transformed data looks like with no issues. Let's just verify entries here. We can see that all the entries which we are getting under this are no issues entries and paid amount is false. That means there are no issues in paid amount. Now let's verify quarantine table now, which will be sent to payments team to cross verify if there are any issues in the entries. So here we can see that if paid amount is null, then we can see that entry is verify paid amount and paid amount check is set as true. If the payment status is null, then verify payment status. But in this case, paid amount is correct. That site is marked as 0. This means that whatever logic we have implemented for this, it is working. as expected. Okay. Now the last part is quick validation. So this final cell we needed to print silver transformed row counts, and it will show the silver control table too. This is again for the understanding sake and to cross verify. If we get stuck at any point, then we'll at least know that okay, till this step we were having these many entries, or some entries are missing, or it is working correctly till this level. Then like maybe the issue is in the next file. So such kinds of small validations we can have it using such print statements. So now let's run this. Okay, here I have done one mistake. I need to change my catalog name here. Let's run this again. Now here we can see that we have 111 entries under products transformed count. For the orders, we have 435 entries. Payments, we have 391 entries. And here we can see this one was our last bronze run ID. Again, this one was last bronze ingested at. And this is our current run ID and updated at entry for the current run under this silver work. Okay, and run status is success. How many records or how many rows we have merged under this run ID, that will get displayed here under this one pipeline run. Okay, so this is how this data gets displayed here. So now we are done with this silver work. We need to move ahead with our gold work now. So for that, we have already created one notebook file, gold work. But before this, I have forgotten, once we are done with this silver work, we need to push that file into our GitHub. Okay, so for that, I'll click on this branch. Here we can see that we have silver work, whatever changes we have done that are getting displayed here. Here it states that M, that means modified, because earlier we have created empty IPYNEP file and we have pushed that file to our GitHub. Okay, that means that GitHub already has this value. So whatever code we have added, that is getting treated as modified. Now let's add the message as silver work completed. Let's say data cleaning and transformation successful. Click on commit and push. Successfully committed and pushed the changes to the branch. Okay, now go back to your GitHub account. I'll just refresh this page. So here, if I'll come to my repository, here we can see that, okay, I'll select the branch. And here we can see that for this branch, it had recent pushes at 28 seconds ago. Now I'll click on compare and pull request. Again, we can see title and comment here. Click on create pull request. It is checking if we have any conflicts. No conflicts with the base branch. Then you can click on merge pull request and then confirm merge. So now we have successfully pulled our silver work, which we have done into our Databricks repos, into our GitHub. Now coming back to our Databricks. Now here we will start with our gold work, where we will perform some business aggregations and we will also implement manual SCD type 2 here.